Join me to solve some Wzari past paper questions from 2022 and 2023. We'll be solving some questions, and then the rest of the questions we'll be solving them in another video lesson. So starting with the first question, we have a tire or car's tire that rotates with an initial speed. So we have omega initial, which is 21.5 radian per second. Okay, the driver accelerates after 6.5 seconds. So we have delta t, which is 6 point delta t. Okay, we have delta t, which is 6.5 seconds. 6.5 seconds. Right, omega final becomes what? Omega final becomes 28 radian per second. So the question is, what is the tire's average angular acceleration during this 6.5 second time interval? So of course we have omega initial, final, and delta t. So of course we'll use average angular acceleration equals to omega final minus omega initial divided by delta t, which in this case, average angular acceleration, of course, equal to 28 minus 21.5 divided by 6.5. And of course, 6.5. Of course, if you're going to use your calculator, you will get 6.5 divided by 6.5. That is because 28 minus 21.5, that would be 6.5. So once you divide it, of course, average angular acceleration will equal to 1, and of course radian per second squared. That is because this acceleration. So here's the answer to the first question. Now continuing or moving to the second question, so we can say the correct answer here is going to be 1 radian per second. Now as for the second question here, it says find the magnitude of gravitational force of a 71.2 kilogram person would experience while standing on the surface of planet Earth. We know that force of gravity, you do know the equation, yes, equal to g, that is gravitational constant multiplied by m1 and then m2 and then divided by the radius square. And gravitational constant, which is given, that is 6.67, okay, 3 times 10 to the power negative 11 multiplied by mass of the person and mass of the earth. And of course here we can go with the mass of the earth first. That is 5.98 multiplied by 10 to the power 24 multiplied by the mass of the person here, which is 71.5 kilogram divided by the radius square. And as you can see here, the radius is given in the table, which is 6.37 multiplied by 10 to the power 6. But don't forget that these are all squared because of this radius square. So once you calculate all this, you get gravitational force on the person is going to be 700 Newton. So the correct option would be option D here. Now moving to the third question here, it says how many radian are equal to 35 degrees? So we've learned that in order we can convert degrees to radian, radian to degrees, or vice versa, we can say. And then, of course, radian to revolutions, or revs to radian, to revs. And, of course, revs to degrees, and then degrees to revolution as well. Here we're converting degrees to radian. Now there is an easy way here. Whenever we have a degree, right, all you need to do is just divide. We have a degree, just divide the degree by 57.3, right? Of course we will get the answer in radian, okay? And if it was in degrees, we could just multiply. But since we're converting degree to radian, so we're just going to divide the 35, because that is what we have, divided by 57.3 degrees. And of course, the answer that we are going to get is 0.61 radian. You may use your calculator. So the answer is going to be 0.61, and that is option C.